In this topic, I want to talk about valuing bonds with credit risk. Let's take a look at the following table. So this is from a snapshot in time, around January 2023. So in January 2023, when the US government was issuing debt, selling bonds, the rate they were promising was about 4.65%. Compare that to US Steel issuing bonds at the same time. They were offering a higher rate, 5.12%. Ford Motor, even higher than that, 5.89%. So sit back and ask yourself the following question. Why do these borrowers need to pay different interest rates? Or said another way, how come the US government can get away with offering a lower rate to bondholders than, say, Ford Motor? How come Ford Motor needs to offer a higher interest rate to entice borrowers to buy its bonds? Okay. Well, hopefully the answer that comes back to you is something like credit risk. There's a greater risk that Ford won't come through with its promised obligation and make its bond payments than the US government. And so in order to entice bondholders to buy its bonds, it needs to offer a higher rate. Okay? So what I want to do now is start thinking about valuing bonds with this credit risk. After all, the yield to maturity that we calculated in the previous topic is based on promised cash flows, not expected cash flows. And there can be a wedge between the two, a difference between the two because of credit risk, the risk that firms or government won't make its promised payment. Okay. Let's look at an illustrative example. So let's take a 3-year, zero coupon bond with a face value of $1,000 and a price of $767.90. It's easy to show that the yield to maturity for this bond is 9% with semi-annual compounding. But the question is this the expected return a bondholder, someone who holds this bond, can expect to receive? Is this the expected return for the bond? Well, let's suppose that the bond has a 10% chance of defaulting. And in that state of the world where the bond defaults, bondholders get nothing. So here we're introducing credit risk. There's some risk that the bond issuer will not make its promised payment. There's a 10% chance the bondholder will receive nothing. Ergo, there's a 90% chance the bondholder will get exactly what was promised to him or her. So what is the expected return? And then what we're going to do is just juxtapose, compare that expected return with the promised return via the yield to maturity. All right, let's jump over to Excel and do it. I'm in the first slide tab, the one associated with slide 4. So here's the information from the problem. We have a bond. Its face value is $1,000. It matures in 3 years. It's zero coupon. Okay. The bond price is $767.90. Okay. And for the purposes of calculating a yield to maturity, we're going to assume semi-annual compounding. So that's 2 periods per year. Okay. Now, just for review, let's calculate this bond's yield to maturity. Again, as an APR with semi-annual compounding. Okay. I claim this number is going to be 9%. That's what I said in the slides. Let's see if that's true. So we're going to use the rate function. So we need to tell Excel what's the number of periods. Well, it matures in 3 years. Okay. And it's semi-annual compounding. So that is 6 6-month periods. What is the payment? You could just put in a flat 0 if you want. You know it's a zero coupon bond. But formulaically, what would we do? 0% times the face value divided by the number of periods per year. Okay, but that is 0. We need the PV. The PV is the bond price. But remember, we need to respect Excel's sign convention. So the price needs to go in as negative. So 0 minus the $767.90. Remember the sign convention. For all those cash flows I'm going to receive in the future, positive amount, I need to pay out money today, negative amount, bond price. Okay. And then finally, the FV, remember that's the face value or big lump sum payment at the end. Here's the 1,000. close parentheses, and we get 4.5%. Well, remember, this is our little r. This is 4.5% every 6 months, right? This is a 6-month rate. To convert a 6-month rate into an APR, we need to multiply it by the number of times it compounds per year, right, which is 2. So that's how we get 9%. So the yield to maturity is a 9% APR with semi-annual compounding, aka 4.5% every 6 months. Good. All right, we're told the default probability is 10%. Remind yourself what it said in the slide. There's a 10% chance that the bondholders get nothing, right? And a 90% chance that they get the full promised amount of $1,000. So the next thing I want to calculate then is what their expected face value payment is. Okay? The promised face value payment is $1,000. What's the expected payment? Okay? Well, an expected cash flow the expected payment is just the probability weighted payment. So we want to weight the states of the world by the probability. We take the probability and multiply by the cash flow or payment we're going to receive in each of those states of the world. So do you agree there's a 10% chance, that's a probability, that we receive nothing, right? And there's a, therefore, 1 minus 10% chance, right, which is 90%, that we receive the full $1,000. The expected payment is a probability weighted payment. Okay? Let's calculate what that is. So equals, there's a 10% chance of getting nothing and a 1 minus 10% chance, aka 90% chance of getting $1,000. You probably got this in your head. The expected face value payment is $900, given there's a 10% chance of default. Okay? Well, then the expected return, not the yield to maturity, the expected return is going to be slightly different. The calculation, so I'm gonna take the same formula I had for yield to maturity, same formula I had before, but this face value payment at the end, which used to be B1, I'm going to replace it with B11, the expected face value payment. So the calculation is going to be identical. However, I'm going to replace the promised payment, the $1,000, with the expected payment, the $900. Hit enter, and now we see the expected return is 5.36%. So just to summarize, the yield to maturity reflects a promised rate of return, right? Everything goes great, no default, 9%. This reflects an expected return, right? It reflects the fact that there is some credit risk, aka there is some probability of default. Let's jump back to the slides. All right, so how do we engage in risky bond pricing? Well, corporations issue bonds in markets where investors have lots of choices. And so we can use publicly available pricing data on existing bonds to infer what investors would pay for new ones. So here are the steps involved. Step 1, find the yield to maturity on a treasury bond with a similar cash flow structure as the proposed bond, the bond you're trying to price. In practice, this means finding a treasury bond that makes payments on similar days as the bond you're trying to price. Second, find the credit spread on bonds with the same level of risk. So you want to use credit ratings for bonds that have a similar payout structure as the bond in question. It's often good to look up firms in the same industry to get as close to an apples to apples comparison as possible. And then you want to add up the two, the yield to maturity of the treasury plus the credit spread to get your bond's promised yield. Okay? All right, let's do a couple of problems. So problem 1 says a 5-year zero coupon bond with a $1,000 face value is priced at $750. The yield to maturity of a 5-year treasury strip is 1.9%. This is an APR with semi-annual compounding. What is this bond's credit spread? And express your answer in basis points. This is a good term to know, especially if you're in the financial industry. A basis point means this: 100 basis points equals 1 percentage point. So a rate of 2.5% is 250 basis points. Okay? So this problem asks us to express our answer in basis points. All right, let's jump back to Excel. All right, so we have a bond. It has a par value of $1,000. It matures in 5 years. Coupon rate is 0%. Okay, the bond one price is $750. Okay, we have a treasury bond that has a par value of $1,000, matures in 5 years. Coupon rate is 0%. These are both zero coupon bonds, and the treasury bonds yield to maturity is 1.9%. Okay. So what we're going to do is find bond one's yield to maturity as an APR with semi-annual compounding, okay, and then compute the credit spread. The credit spread is going to be the difference between this bond's APR with semi-annual compounding and the treasury bonds APR with semi-annual compounding. Okay? We're going to compare this bond's yield to maturity with the treasury's yield to maturity. The difference between the two is the credit spread. Okay, so let's do that. We now know we're going to use the rate function. Okay. All right, first, number of periods. Well, 5 years, but again, semi-annual compounding means 2 periods per year. Okay. What's the payment? Again, 0. This is a zero coupon bond. But if you want to go through it formulaically, it would be 0% times the par value divided by 2, because it's semi-annual. Okay. The PV, remember, obey Excel's sign convention. We're going to do 0 minus the bond price. And then the big FV, that's the face value at the end of 1,000. Okay. What's going to come back to us, remember, is a 6-month return, right? 6 month. So to make it an APR, an annual percentage rate, because we're going to get back a 6-month rate, we need to multiply by 2. Okay. And we get 5.84%. So this bond has a yield to maturity, as an APR with semi-annual compounding, of 5.84%. Treasuries have a yield to maturity of 1.90%. So we say bond one's credit spread is the difference between the two. 3.94%. But remember, the problem asks us to express this in basis points, so this would be 394 basis points. I'll bold this as well. 394 basis points. Good. Next problem. You're an investment banker specializing in helping corporations issue bonds. A client firm wants to issue a 5-year semi-annual coupon bond that has been rated BA by Moody's. Currently, the average BA bond has a credit spread of 250 basis points. The yield to maturity of 5-year Treasury semi-annual coupon bonds is currently 1.9%. If you price these bonds at par, estimate the rate at which you would have to set the coupon. Okay? All right, let's jump to Excel. Next slide. So here are the inputs to the problem. Par value for this bond, $1,000. Maturity, 5 years. Payments per year, 2. Okay. The Treasury bonds yield to maturity is 1.9%, APR, semi-annual compounding. The proposed bonds credit spread is 2.50%. Where did this come from? Well, bonds that have the same credit rating as this bond have a credit spread of 2.50%. Okay. All right, so the question is, what coupon payment? What coupon payment? What coupon rate do we need to promise investors to price this thing at par? Now, some of you may read this problem and know exactly what the answer is immediately. It's actually, you can get the answer quite quickly, but let me walk you through it slowly. So first, remember, we want to price the bond at par. Okay? We want the bond to sell at par, the bond price to sell at par. Remember what selling at par means. It means the proposed bond's price will exactly equal the par value. So we want to go out into the marketplace and sell this bond for $1,000. The question is, what coupon payment is necessary so that we can sell it for $1,000? Okay. Well, what coupon payment is needed? Well, that's solving for the PMT, right? The payment. So this is, we're going to use the PMT function. Okay. What discount rate is appropriate for these bonds' cash flows? Well, it's going to be what? It's going to be the sum of these two. It's going to be the Treasury, it's going to be the Treasury's yield to maturity plus the credit spread. So the appropriate discount rate or yield to maturity of these bond cash flows is the sum of these two, 4.4%. Now, this is an APR with semi-annual compounding. So this divided by 2 is the actual rate. Right? 4.4% APR with semi-annual compounding means 2.2% every 6 months. Okay. How many periods with this bond? 5 years, 2 payments per year. Okay. The bond price, right? Obey Excel's sign convention, make it negative. The FV, right, which is the face value in the bond context, is the $1,000. Close parentheses. And so you need a coupon payment of $22 every 6 months, right? Coupon payments are made every 6 months. So do you agree that is a coupon rate of 4.4%. So the coupon rate you need to promise for this bond to sell at par, aka $1,000, you need to promise a coupon rate of 4.4%. Now, some of you will realize, oh, I could have got that really quickly. Why? Because remember what we showed in an earlier video. When a bond is priced at par, that means its coupon rate equals the yield to maturity. Remember that? So if the bond is priced at par and the yield to maturity is the sum of these two, it's the Treasury yield to maturity plus the credit spread. Remember, the credit spread reflects the fact that this bond's issuer may not make all its payments, right? That's reflecting the credit risk. So that's 4.4%. If the bond is priced at par, the coupon rate must also be 4.4%. Okay. So some of you might have just jumped to this answer immediately, but it's good to walk through and get this answer step by step as well, so you can see the consistency. Good. And that's it. So what have we done in this topic? We've started with our foundation of bond pricing, and we've added a brick on top of it. we figured out how we can price bonds with credit risk. That is, bonds that have some risk of default.